In this segment, we'll continue our JDBC discussion by doing a walkthrough of a JDBC example app. With the basic overview done, we can walk now through the JDBC example program supplied with this lecture, and the code for it is right up here. The example program requests a customer first and last name, and then queries the Bakery 5 database to find prior product purchases for the customer and list those purchases for the customer's reference. Let me run it here briefly to show you what I mean. So here we go. Enter the first and last name. Let's do Terrell Arsd. Able to pronounce that. And as you can see, it lists all the purchases he's made, and it does those in descending order of the number of purchases made, and then requests a list or series of product IDs to purchase. So referencing this list, we might say, oh, well, we purchased Napoleon cake a time before like that, so I'll do 46-11, and then we can add in, I don't know, 70-GON there. And just for the heck of it, we'll add another 46-11. And when we are done with input, Control-Z there, that ends the program. And what it did was take that list of purchases and enter a receipt. It doesn't show the receipt, but it is present in the database. And we'll come over here, take a look at the database. We can see it then. For Ardst there, and you can see that we just did add a receipt ID number 100,000 as a matter of fact, and a total of 2813, and we can also look at the line items for that and see that we did two of them, and notice that the two purchases of 46-11 were grouped under a single line item with a quantity of 2. Yeah. So now that we know what the program is supposed to do, let's start our code review with line 151. Now this uses the class Driver Manager to get a connection. Driver Manager is a library class in JDBC, and it hunts the class path for a JDBC driver and then uses the driver to initialize and return a connection. You pass getConnection 3 parameters, supplied as command line arguments in our example code. The first parameter is a URL, somewhat like the one here in the notes. Now this URL identifies in one string the type of the resource, which is JDBC MySQL, meaning a MySQL database accessed via JDBC, the host machine, localhost, though any internet host name would be allowed, of course, the port on which the DBMS may be accessed, 3306 for MySQL, and then a slash and the database name to use. So the resource has to be JDBC MySQL, and then the : // the usual drill there, and the host name, port number, and database name. Now, compared to the first parameter, the second and third ones are simple. They're just the username and the password with which to log into the database. Now, if anything in that complex first parameter URL here is wrong, or if the username or password fail, then getConnection throws a SQL exception. And this is an almost universal reaction of any JDBC class to a problem. So any JDBC interaction code should be wrapped in a try block, like ours here, that catches and handles or reports SQL exceptions. On line 176 through 178 is our example. The getMessage method works fairly well for debugging. It reports the same sort of textual errors you'd see in a SQL text client if you gave bad SQL or an unknown database and so forth. Question 1. You can get a more programmatically usable error report from a SQL exception via the SQL state string. Look up SQL exception and find what method gives you that string, and then check online to see what typical contents are for such a string. Coming back from a pause, the method getSQLState, unsurprisingly, returns the SQL state string from a SQL exception. And as the API docs indicate, this state string follows one of two standard formats. But in either standard, it's a string of digits giving well-defined standard error codes. which an app might use to provide more user-friendly explanations of what went wrong. Now, once we have our connection set up, then lines 153 through 155 up here, query for a customer, first and last name, and then read that in, and finally call getCustomer here to find a list of customer IDs corresponding to that first and last name. And the list is returned as a list of integers, as you can see here. So let's look at method getCustomer. It's up on lines 51 through 69, and it's a good vanilla example of using a statement to do a simple SQL query. So first, line 58 uses the connection to create a statement, and then lines 59 through 60 use the statement to execute a SQL query. Now, making the query is pretty straightforward. You build the SQL command string using Java string operations, and then you pass it to the execute query. And note, by the way, there should be no semicolon at the end. And you cannot join a bunch of SQL commands together. It has to be a single SQL command that you pass to execute query. If you want several queries, make several execute query calls in a row. Now, as mentioned in the overview, queries return result sets, like our RST here. This is an iterator object that returns one row of the query result at a time. Now, result set iteration is quite compact. Your typical iterator object provides methods like next and hasNext to advance and test the iterator, but the result set does it all with just the method next. In its initial state, a result set points before the first row of the result. So you must do a next call to even access the first result row. From there, each successive next call advances the result set to the next result row and returns a Boolean indicating whether you have advanced to a valid row, true, or have advanced past the final row, which is false. If the result set has no rows, then the initial next returns false right away. And all that means that a loop like the one on line 61 here succinctly starts the iteration and then continues as long as there are rows, stopping when a next call, possibly even the first one, advances past the end of the result set. Now, once a result set is positioned at a row, you can use any of its large collection of getWhatever methods, getInt, for instance, in our example, to get the column values of the current row. Columns may be identified by their position, as we do here on line 62, or by column name. Now, somewhat irritatingly, the column position numbers are 1-based, so our line 62 here is in fact returning the first, and in this example the only column in the row, the ID number that was produced by the select that we just ran. If there were more columns in our query, they'd be retrievable as column numbers 2, 3, and so forth. So our line 61 through 62 loop here executes for as many rows as were found to match the first and last name passed to getCustomer. That's probably 0 or 1 rows, but it might be several if several customers have the same first and last names. However many we get, we add their IDs to return and then return that list. Now, you must use the right form of getWhatever. For instance, getString for a varchar column or getDate for a date-time column. If you use the wrong type, you get a thrown SQL exception. Ditto for bad column numbers, which happen most often from forgetting the 1-base numbering and trying to get column 0. getCustomer's try block, by the way, doesn't even catch SQL exceptions. They are thrown all the way back to the main, thus getCustomer throws SQL exception. The try block is there for other reasons we'll discuss in a moment. Now, question 2, exploring a little bit about result sets. If you don't like 1-based numbering of columns, or if you'd like your code to survive minor rearrangements of the columns in the select clause, then you may also identify columns by their name or label. Look up result set and come up with an alternate way to do line 62 without using a column number. Coming back from a pause, what we could have done here instead is said getInt and put a quote using the actual column name, quote ID there. Now, as you probably noticed, every whatever, getInt, for instance, method, comes in two forms, one taking a column number and the other taking a string column name or label. Put that back. Question 3, I'm sorry. Check out the variety of get XXX types just to get an overview. Some are quite sophisticated. They're all not just getInt and getFloat. For instance, what would you use to retrieve a decimal column with its arbitrary precision? Coming back from a pause there, I'd be using getBigDecimal. That'd be the best choice because it returns the built-in Java big decimal type that offers arbitrary precision. Question 4. Not all of the getWhatever methods return standard Java types. Look closely at the return type of getDate. What exactly does it return, and how does that relate to the java.util.date class? Answer 4. It returns a java.sql.date object, not a java.util.date. The former, the SQL date, is a subclass of the Java util.date, with a few special methods of its own, especially ones for parsing and printing data using SQL formats. This type variation is a source of confusion and bugs at times. Watch out for JDBC types that are special to java.sql, even though they look like standard Java types and have the same class name. Now, looking at a really sophisticated use of getXX methods, as a final example, take a look at the getBinaryStream method. So here's result set API docs, and here's getBinaryStream. Right? Now, this is one of several get methods that return not an immediate value, but an input stream, or reader in some other cases, if you look farther down, that may in turn be used to read the column value as though it were a file of bytes or chars. These are used with large columns like var binary and blob, where you might not want to get the entire column value in one big slug of bytes or characters, but rather incrementally via a series of read calls. Depending on the DBMS you're working with, the input stream or reader may go all the way back to the DBMS to fetch more of the column on each read call. So the large data transfer is done on an as-requested basis, instead of slowing down the execute query call with a big and possibly needless data transfer when it's first executed. So as you can see, we've gone back to our code here, and as discussed in the overview, closing result sets, statements, and ultimately connections is important, and it's easy to screw up. Forgetting a close call can cause subtle intermittent bugs, such as leaving some table rows locked because they were part of a result set that JDBC and the DBMS thinks you're not yet done with. It's a good idea to close things in the right order, too. Result set, then statement, and then connection. Though generally if you close a parent object like a connection, it automatically closes any objects it created for you that are not yet closed. So in our code, we might have put something like this right before line 63, or right after line 63, before line 63. We could have done RST close to close our result set, and then we could have done stm.close to close our statement. But we didn't do that, and it would have been a bug if we had, possibly leaving RST and stm unclosed. Why? Under what circumstances might that have happened exactly? Coming back from a pause, well, if a SQL exception were thrown, for instance, by line 62 when we did a getInt, then those close statements would never occur, and the things would be left unclosed. The possibility of thrown exceptions evading your close calls is a major source of bugs in JDBC code. The fix is to use Java's finally keyword, as we do on lines 68, 6 through 68 down here. Virtually every language that offers an exception system also offers a way of saying, but do this cleanup code for sure, even if an exception is thrown. And that's done by keyword finally in Java. If code enters this try block at all, no matter how it exits, even if it bombs out with an exception right on line 58, still the finally block will be executed. But that's a problem in its own right, because depending on where in the try block an exception is thrown, STM and RST may be left uninitialized and thus not in need of closing. So we set them to null on lines 53 and 54, and then in the finally block, we could, if we wanted to, write something like if RST is not equal to null, then RST.close, and likewise for statement, like that. But there's a better way to do this. Writing statements like that will work, but believe me, after you've written a block of code like that several dozen times in a large JDBC app, it gets pretty tiresome, and it clogs up the source, since you have to do it everywhere. Instead, most JDBC developers set up a one-line function like our closem here, and just call that, passing all things that need closing. Now, commented out lines 31 through 39 show one traditional version of that general closem function. As you can see, it takes a connection, a statement, and a result set as parameters, any or even all of which might be null. It closes the non-null ones in the correct order. And since even a close call can result in a SQL exception, each close is in its own try-catch block. Trying to recover, by the way, from a failed close by retrying it is a waste of time. So the catch blocks do nothing. In a professional version, they'd at least log the event. But we can do better with a bit of Java foo. The closem version we actually use is on lines 42 through 48 here. It takes a variadic list of objects, all of which are presumed to have a close method needing calling unless they're null. This lets us pass as few or as many closable things as we like. Compare the calls, for instance, on lines 67, which has 2 parameters, with that on line 138, for instance, which has 4. The for loop, or for each loop, I should say, up here again on line 43, iterates through the variadic list of objects, variadic array, in fact, and then for non-null parameters uses reflection on line 46 to call the close method that is presumed to exist for each parameter. Any conceivable exception thrown from line 46 will be derived from throwable, so line 47 catches any such exception and logs it. And you can use this version of closem to close anything you like, even non-JDBC objects, so long as they have a close method. This isn't a course on Java, but JDBC is a Java technology, and this is a nice chance to work in some advanced Java. So answer the following. If the close method takes no parameters, what is the obj parameter for in the invoke call on line 46? Read the Java reflection docs if you need to, starting with java.lang.class and then moving to java.lang.method. Coming back from a pause, get method returns a capital M method type object representing the parameterless close method, which method is called by the invoke call. But any non-static method, even if it's nominally parameterless, still gets a hidden this parameter pointing to the object on which the method is called. There really is no such thing as a truly parameterless non-static method. A call of obj.close is really passed obj as it's this parameter, as though we had called close and passed obj. When you call invoke, you must explicitly pass the object to which the method applies, thus the obj parameter. Now, in the next segment, we'll wrap up the JDBC example code looking at prepared statements, generated keys, and some other issues.